Hey math fans, we're on section 2.4.1. Let's get started. Here is a list of key features that we will be investigating for each function. On the screen are two graphs. The graph on the left is something you'll see more or less in upper level math courses, not so much in this course, but it does have a lot of features that I do want to talk about. And then on the graph on the right is an exponential, and this is something we will be looking at. The graph on the left has several what are called relative minimums. That's a relative minimum. This is a relative maximum. This is a relative minimum. And this is a relative maximum. If it were to have an endpoint, we would call this an absolute maximum. Or if there was an endpoint here, it would be called an absolute maximum. The graph on the right has no relative minimum. It continues on to negative infinity. And it really does not have a maximum either. It approaches this line, this dotted line, which is called an asymptote. Asymptotes can be found with exponential functions and not linear functions. The graph on the left has 1, 2, 3, 4 x-intercepts with one y-intercept right here. The exponential function has one x-intercept here, and then at 0, 3, that would be the y-intercept. The function on the left is increasing and decreasing at different spots. We read it left to right. So as I go from left to right, the function is decreasing. But it turns around here and starts to increase, but then it turns around and decreases. We would have to explain to the reader during these different domains, it is either increasing or decreasing. The function on the right is just continually decreasing. The function on the left is positive in certain areas and negative in certain areas. The graph on the right is positive until it reaches the domain of whatever that is, 1.5, and then it becomes a negative function. The function on the left has no asymptotes, where the function on the right has an asymptote at y equals 5. Example 1, a taxi company in Atlanta charges $2.75 per ride plus $1.50 for every mile driven. Determine the key features of the graph of this function. First of all, this graph is linear, as you can see from the graph provided. The graph of the function intersects at 0, 2.75 right here, and it will never intersect the x-axis, therefore no x-intercept. Reading the graph left to right, the y values are increasing. This is a positive function because notice that all of the y values are positive. The least y value would be this point right here at 2.75. There is not going to be a maximum because theoretically this continues to infinity. But this has a relative minimum at 2.75. The domain of this particular function, since it can only be positive miles traveled, will be x is greater than 0. And finally, since this is a linear function, there will be no asymptotes. Example 2, a pendulum begins at a height of 80 centimeters. After each successive swing, the pendulum reaches 90% of the previous height, a behavior can be described by the set of ordered pairs in the table and determine the key features of this function. We're going to go ahead and graph it, but even before we graph it, you can kind of see as x is getting larger, you can tell that this will be a decreasing function because the y values are getting smaller. When we graph the function, we recognize that this is going to be an exponential function. It is losing 10% of its height for each pendulum swing. So this is an exponential function. The function intersects the y-axis at the point 0, 80 as indicated. There will be no x-intercept because notice as the height gets smaller and smaller, it approaches 0 but never intersects 0. As previously stated, as x is increasing, the y values are getting smaller or decreasing. This is a decreasing function. However, this is a positive function because all the values of y are positive. It never goes below the x-axis. Exponential functions do not have a relative minimum because the graph continues to approach 0 but will never quite get there. But it does have a relative maximum up here at 80 centimeters. The domain for this one's a bit tricky. The domain will start at 0 swings. However, theoretically, there's an infinite number of swings, but in reality, it would stop swinging eventually. We just don't know where. So the domain of this function would be any whole number. And finally, since it's decreasing almost to 0, but it will never quite get there, we call this an asymptote. So therefore, at y equals 0 is the equation of this asymptote. A ringtone company charges $15 a month plus $2, create a graph and determine its key features. Here's the graph, and notice it's discrete data. It's not going to be a continuous line because you can only buy 0 ringtones, 1 ringtone, 2 ringtones, 3 ringtones. This is a linear function, but it does have a restricted domain to whole numbers. The graph crosses the point at 0, 15, but there does not appear to be a point where it will cross the x-axis, so no x-intercept. This function is increasing. This function will also be positive because it's never going below the x-axis. So this is a relative minimum here at 15. The domain can be any whole number greater than or equal to 0. And again, this is a linear function, so no asymptotes. And that's going to do it for this section. We'll see you in class.